Hello, my name is Dr. Koka, and in this video, we're going to be doing an extraction with the product from the distillation of 2-methylcyclohexanol. So at this point, we should have an alkene or a mixture of alkenes as our product. So we have collected that from the distillation in a graduated cylinder. We have about just slightly above 4 milliliters of product mixed in with other things like water. So we're going to do an extraction to try to purify our product. So for the extraction, we're going to use a separatory funnel. So as a reminder, separatory funnel has a stopcock and currently is in the closed position. So stopcocks have a little hole there that you can see on the Teflon stopcock. And when it's in this position, it is closed off. When we turn it in this direction, that hole is pointing up and down. So any contents in the separatory funnel will be able to get out of the funnel. We also have a stopper on the top, and so that's something we want to keep on when we're using our separatory funnel. So now we're going to add our product to our separatory funnel. And again, we want to make sure that the stopcock is in the closed position. We want to add our product by using perhaps a glass funnel just to avoid any accidents. And then we're going to add 2 milliliters of brine. So brine is a solution of water and sodium chloride, so it's a saturated solution of sodium chloride in water. We're going to add 2 milliliters of it into a graduated cylinder. I already have done this, and then transfer it into our separatory funnel. So at this point, we remove the glass funnel, put the stopper on, and we gently mix the contents inside of the separatory funnel a few times. We want to open up away from us the bottom or the stopcock, release the pressure, place the separatory funnel back on the ring clamp. We remove the stopper, let it sit for a minute or two, and then we're going to drain out the aqueous layer. So here we have our alkene product. We really don't have it dissolved in any organic solvent. So normally when we do extractions, we'll have some sort of organic solvent like ether, dichloromethane, for example. But here we have just our product, and we have it mixed in with water and brine. So our aqueous layer should be more dense than a non-halogen organic product like an alkene. But if you're not sure, you can double check which layer is which by adding a little bit of water. So with a squeeze bottle, you would want to add a little bit of water to this and see which layer grows. Okay, so in this case, our water layer is actually the aqueous layer is the bottom layer. So we're going to drain that out, and we don't want to keep that aqueous layer. We're just going to waste it. So we open the stopcock, drain out the aqueous solution, and we're left with our organic product in the separatory funnel. So at this point, we want to transfer our product into a small Erlenmeyer glass. And we want to open the stopcock again, drain it into that Erlenmeyer flask. Notice, by the way, I'm doing this without the stopper. So anytime you want to drain out anything from the separatory funnel, you always want to remove the stopper because it allows air to come inside of the separatory funnel, and it allows the contents to exit from the bottom a lot easier. If you don't remove the stopper, then it moves really, really slow out the bottom. Okay, so here is our product. So you can see that is pretty much one single layer, and it's a colorless, clear liquid. We're going to add sodium sulfate to it, which is a drying agent. So when we remove the aqueous layer, we're removing basically over 90% of the water, if not more, out of or away from our organic product. Now we're adding a little bit of sodium sulfate to remove any trace amounts of water, and we can't really see with our eyes that are still trapped inside of our organic product. So we just need a small amount of sodium sulfate at this point. Add that in. And you can see that the solid sodium sulfate is not soluble in our organic product. It's just there to get rid of the trace amounts of water. We let this sit for about 5 minutes, and then we can conclude the rest of the experiment.